So we're going to go on with talking about fractions today. So in this first part, we're talking about changing from a fraction to a percent. So Lila wants to rewrite 10/25 as a percent. She decided to represent 10 over 25 in the first picture. So she made a square with 25 smaller squares and shaded 10 of them. That's 10/25. How many sets of 25 will she need to make 100? Everybody, how many is she going to need? She's going to need 4. So how many sets of shaded squares will she need? You're going to need 4 of those, right? How many total shaded squares will she end up with? 40. So this is what's happening here. She's starting with this and going, oh, if I had 4 sets of those, I would have 100 small squares in total, and of those, 40 of them would be shaded. So when Lila multiplies the number of shaded squares by 4 and the number of total squares by 4, does the amount of shading compared to the total shares change? So that's a more difficult question. So again, does the amount of shading compared to the total squares change? What do y'all think? Yes?
It seems pretty accurate to me because there's
So wait, hang on. You said it seems pretty accurate to you. It's a yes or no question. So let's see if we can answer it that way.
yeah, I think it's accurate.
Yeah. So does it change? So let's answer the question that was asked. Yes?
I'm not really understanding the question.
Okay. So if we took this and did it as one big square, so comparing it to this, right? This is the part of this whole square that's shaded, right? When we do this, have we shaded the same part of this whole, if we did this as like this was one big square, have we shaded just as much of this as we have of this, or if we shaded more, or if we shaded less? So maybe it would be helpful to think about if we took this, if we stacked those two together and stacked those two together, it would look like that, right? Is this the same part of the square as this is a part of the square? Yeah. So does the amount of shading change? No, the amount of shading didn't change. We have shaded the same fraction of the square that we did before. So let's move on. So remember that multiplying by the number 1 does not change the value of the number. 7 times 1 is still 7. 12 times 1 is still 12. This is called the identity property of multiplication. And before you poo-poo this and go, yeah, not a big deal, do you know that my calculus students use this idea all the time? Okay. It's an important idea to math. If you multiply by something that is equal to 1, you don't change its values. So when the numerator, that is the top number, and the denominator, that is the bottom number, of a fraction are multiplied by the same number, some people like to say the fraction is multiplied by a giant 1. For example, 10 over 25 times 4 over 4 When you multiply by 4 over 4, what is 4 divided by 4 equal to? Everybody. It's equal to 1. And when you multiply by 1, do you change the value? No. Do you change the way it looks? Yes. And that's what's going on. And that's what my calculus students use all the time. We used it today in class. They use that all the time to take an expression and change it into something else that they would rather have. They multiply by 1, and it's way more complicated than 4 over 4, but that's the idea is still the same. So, why is the fraction 4 over 4 called a giant one? Well, 4 over 4 is equal to 1. But 4 over 4 looks bigger than just 1. All right, it takes up more space to write it if your numerals are the same size. So, each fraction is shown next to a giant 1. We're going to multiply these together to get a new fraction. So 9 times 6 is 54, thank you. And 25 times 6 is 150. I heard of 125 from somewhere. All right. So this is equal to 6 times 3 is 18. 3 times 15, 45. So you can write new fractions by multiplying by a giant 1. So on these, they want you to figure out, well, what do we want to use as our giant 1? So if I've got 5/7 times some giant 1, we're going to get 40 over something. What did I multiply the numerator by? Yes, sir? 8. So I have to multiply the denominator by 8. And 8 times 7 is 56. Here, we started off with 5/7. We're going to multiply by a giant 1. What did we multiply the denominator by? Yes, sir? 10. So then everybody, what do I need to multiply the numerator by? 10. And we're going to get 50. So this lets you find what are called equivalent fractions. So using a giant 1, you can rewrite any fraction as a different fraction that represents the same portion of a whole, the same fraction of the whole number. Fractions that are equal but that are written in different ways are called equivalent fractions. They have the same value, they just look different. So Adele, Carla, and Lisa are reading the same book. Each has read a different number of pages as described below. Adele has read 5/8 of the book. Carla has read 12/16 of the book. And Lisa has read 13/24 of the book. So we're going to try and decide who has the most left to read. Oh, not who's read the most, but who has the most left to read. Well, we'd like to compare these, but we can't compare them easily because they don't have the same denominator. Now, before I jump in and try and find, yes?
Oh, no.
What were you going to say? Tell me.
I was going to say that we have to, make them the same denominator.
Okay, yeah, we want to make them the same denominator. That's exactly right. I'm going to do one thing before I try and find a common denominator for these. What do you think I'm going to do before I try to find a common denominator for these? Yes, ma'am.
Simplify.
Yeah, which one?
Carl's.
Yeah, Carla is 12/16. Can I reduce that? Can I simplify it? Yes. 12/16 is equal to 3/4. That's going to make my job of finding a common denominator easier. So this is a theme that's going to run throughout a lot of the problems that we do this year. Is if you can reduce or simplify a fraction first, it's almost always to your advantage to do that. It's going to make life easier for you. Now, occasionally I have students who, I don't know, don't believe me, and they never reduce anything. And I'm like, when they miss it, I point it out to them. I try to be polite about it, but I'm like, why didn't you reduce? It would have made that so much easier. Oh, I don't like doing that. Okay, so it was harder and you missed it. That's a bad combination, isn't it? All right, so, yes?
I think I found, for this problem, you probably want to use.
Okay, I haven't asked yet. Just be patient. I'm trying to get some other people involved as well. I appreciate your enthusiasm, though. So I want everybody to think about this for a moment. What denominator could we use? Do not answer out loud. Do not raise your hand just yet. To compare the proportions that they have read. And then I also want you to think about this. Is there more than one that we could use? If you have thought about it already, discuss with somebody near you. Go. All right. Sam, calm. All right. So, what's one number? All right. What's one number that we could use? Yes.
48.
How much?
48.
48? We could absolutely use 48 to do this. There are others that we could use, yes? All right, we could use 72. I already called on you once today. Yes. We could use 24. It is not wrong to use any of those. It is your choice. And you may have a preference that someone else doesn't have, and that's okay. But we do need to get them all to have the same denominator. So whatever is the denominator of your preference, change all three of those into a number with that denominator. Go. Whatever one is your preference. All right, so, Nyla, which denominator did you pick? 24? All right, so tell me what your new fractions are. Okay, okay, I'm not going to do that, but because I want to compare them, why would I change the denominator to something different than everybody else? Right? Now, I understand it is a reflex in math. You see something that can be simplified to automatically want to simplify it, but it makes it harder to compare. But that's true. Go on. Exactly right. Thank you very much. 15, 18, 13, and 24. Okay. Did someone do it with 48? Lots of people did it with 48. Cool. All right. Rory, tell me about 48. What's the numerator for the first one? Yes? Yes, and this one? 26 over 48. Thank you. Did someone do it with 72? Nobody actually wanted to do it with 72, which I fully understand. Okay, either way, which girl has read the largest part of the book so far? Anybody? Carla. And then to show work for this, you would say, all right, Carla has read what? Let's do the 24. 18 out of 24 of the book. While the other two read 15 out of 24 or 13 out of 24. The interesting thing about this problem is we never decided what it originally asked us. Who has the most left to read? Yeah, Lisa has the most left to read. She's barely read over half. Whereas, as Nyla pointed out to us earlier, Carla has read 3/4. which is more than a half. All right, let's move on. So, which of the events below is most likely to happen? Justify your answer by rewriting the portion in a different form. In each case, show your thinking with pictures or with labeled calculations. So, if we're going to compare 4/5, 78%, and 7/10, what do you think is going to be the easiest thing to compare all of them to in the denominator? Yes. Yeah, change them all to percents probably is the easiest thing to do. So let's do that. If we've got 4/5, and it said show the calculations, what giant one can I multiply by here? Yes. I can multiply. Wait a minute. Did you say 20? Okay, sorry. I thought someone else said it. So that's going to be 20 over 20. So that's 80 out of 100. If you want to write 80%, that's fine. I'm just going to change this to 78% by definition is what over 100? 78. And 7/10, what's a giant form of 1 we could multiply by here?
10.
Well, okay, let's not say 10, because is 10 1? So let's say what? 10 over 10. 10 tenths or 10 over 10? That's 70 over 100. So which event is most likely to occur? Yeah. The teacher will assign homework today. If it's this class, it's 100% chance that the teacher's assigning homework today. Your homework is, again, out of your book. We'll have worksheets now and then, but the majority of the time it's going to be out of the book. And I believe we have some time still left. Oh yeah, we have a little over 10 minutes still left, so you can get started on it at the very least. Yes? Oh, okay.